Okay, Pratap Rao is going to give his presentation.
I'll just tell you a little bit about myself. So I'm an assistant professor at WPI here. This is my 5th year at WPI. The two major areas that I work in are thin film solar cells and catalysis. And this is neither one of those. This is sort of a third area that we've started working on recently in my lab. Hopefully I'll have some inventions in the first two areas to share with you sometime in the future, but those are kind of at the basic research stage so far. So this is something we stumbled upon in my lab. So our expertise is making nanostructured inorganic materials. So we make metal oxides, sulfides, and many other chemical substances in the shape of nanostructured thin film materials. And we were able to use that here to develop these coatings. So the top right is what they look like. So that scale bar is, they're all 1 micron scale bars. And so these are composed 100% of polystyrene. So we were actually able to make an inorganic nanostructure, use that as a template to deposit the polystyrene and then remove the inorganic part, leaving behind just the polystyrene in this nanostructured shape. So it has this porous filament structure, and it is very, very hydrophobic. So over here on the left, we have a contact angle measurement. It's a 164 degrees water contact angle. So put that in perspective, if you have a flat material, even if you chemically modify it to make it very super hydrophobic, the largest contact angle you're going to get is something like 120 degrees. So this very high nanostructured surface, it uses what's called the lotus effect to make the surface so-called super hydrophobic. So the water contact angle is 164 degrees. The roll-off angle is 2 degrees. That means you tilt the surface by 2 degrees, water will roll off of it. And some other interesting things also happen. So water will actually bounce right off the coating, right? So it's very hydrophobic. We also did antimicrobial tests, and it reduces the growth of Listeria by a factor of 100 and E. coli by a factor of 10. So those are very common food pathogens. So what we're going for here is a combination of self-cleaning, antimicrobial, safe, by virtue of containing only polystyrene with no inorganic nanoparticles or anything else like that in it. Durable, we've put it through a dishwasher so far with no loss in function. And economical. So compared to some competitive to other coatings which use polymers such as Teflon, the polystyrene is a very cheap polymer. So this is still at an early stage in our lab, and we are working on chemical functionalization of this, making the deposition of these coatings faster and cheaper. But at this point, I'm looking for just networking opportunities and advice, commercial direction input from all of you. Thank you.